morning. Our group is going to talk about the glass fiber reinforced concrete. And our group is composed of Sara Faye, Gfrc, Hamdan Sabiri, Nada Salim, Omar Omer, Ahmed Saeed, and me, Hamdan. First, I'm going to talk about the table of contents and what we're going to cover in this presentation. First of all, it's the introduction, which is what we're going to explain what the glass fiber reinforced concrete is, and then the history, how it was evolved, and when was it established, and its first factor in Egypt. And then the design considerations, what contractors and architects supposed to put in mind when dealing with glass fiber reinforced concrete. And then the cup system manufacturing of Gfrc. The shipping considerations, installation methods, quality control, local prices, advantages and disadvantages, applications, and the conclusions, and if you have any questions. Then let's just start with defining what Gfrc is. It's basically the replacement of conventional large aggregate and cylinder bodies. And it's a composite material, like it's glass fibers with a layer of cement and silica sand. And then mostly it's a non-load bearing curtain wall for exterior cladding. Then the properties of Gfrc, one of its very well-known properties is that it's very lightweight compared to the local concrete or any other material. And then it's durable and it does not undergo any rotting or corrosion. And it has a high structural, tensile strength and impact strength as well. And it does not burn the fiber. Then one of the main reasons why a lot of engineers prefer to use Gfrc is because it enables architects to take their creativity on a further level. Because of its properties previously mentioned, like its high structural and high tensile strength and high impact strength as well.
Also, facade is like it's more used for facades and landscaping. Yeah, you can do whatever you want to.
And then these are some examples for the usage of Gfrc in Egypt. There's campus training campus, and this is the chemical civil.
Where is the Gfrc used? Here, but these and this arch and all this side. The arch is Gfrc is the thing on top.
And the muscle. Then moving on to the history of Gfrc, it was first recognized by the Russians in the 1940s. And there was a problem when it was first recognized, and they weren't aware of this problem at first, which was the alkaline nature of the cement, and it clashed with the glass fibers. So they in 1967 they re-modified the Gfrc and by putting alkaline resistance or in the glass fibers. So that would make it work better with cement. And then the first building to use Gfrc was built in the US in 1974. And basically it had a lot of Gfrc in the facade. And in 1997 that was the first Gfrc factory that we used. And now we're sort of
talking about the design, the first and basic thing about the design is the shape and the color and the feel and the schedule and how like everything regarding to how it looks. And then we calculate the load onto the Gfrc. If there are gravity loads or wind loads, it's calculated and put on a and everything is put on to the building to see where are the critical panels and everything. Gfrc paneling techniques, what kind of techniques would I want, design planning system. Now, the strength of the Gfrc itself depends on several things. The glass content, if you have a higher percentage of glass fibers, then it's a lot stronger. Fiber size, the longer it is, the more strong it is. The fiber compaction, distribution, orientation of the fibers. If I'm spraying like this or like this, further on you'll see how it's sprayed on and how it's manufactured, and the degree of cure, and how much time is needed to cure. And the variables here are so large because its applications are huge. Now we want to, and also in the design process, as I mentioned earlier, the support elements, like what are you going to use? Steel studs, tracks or angles, how are you going to place them, where are they placed, bolts and adhesives and blocks to align every panel together. Design considerations, the most critical thing, the criticality in the Gfrc in the panels must be designed for, especially for crease and drift, because these are, they do have tolerance, they can expand and contract. Design embed in concrete slabs. Where in the building would I need a steel thing that goes up? This is a flex anchor attachment detail, which is a type of critical panel technique. Like this is a solution for critical panel. And also we have the wind loads play a really big role, and not as much in Egypt, but like in the US, the wind speed could reach to 150 miles per hour. But in Egypt, the average is 50. And we can see that. But if you're designing somewhere here, like in this place, then you need to put it into consideration when if you're doing a tall building or anything. And the procedures follow just like in IBC, and you have to calculate the positive and negative, the height and interpolation between the control lines of the wind speed and current. Now Sarah will speak about the composition of Gfrc.
About the composition of Gfrc is mainly composed of fine aggregate, usually silica sand, Portland cement with a ratio 1:1, glass fibers, typically from 3.5 to 5%. We can administer this one. Sometimes we have to do accurate or loose attachments with the shipping, and after we carry out the finished product with the claim. The manufacturing process, we start with designing the mold, where we're going to pour our mixture. The material of the mold